Hey everyone, it's Ashpreet, and today I want to talk about an experimental feature called agentic reasoning, where the agent works through a problem step by step before presenting a response to the user. We can think of this as chain of thought and tool use, but with the ability to backtrack, correct, and validate the reasoning steps as needed. Now, I want to be very honest and upfront. This is not a replacement for the O1 models. In fact, the first few examples we're going to run is where this fails. So it does not give the right response. But with that out of the way, there are many cases where we want the agent to think through the problem step by step, to run the tools beforehand, see if it makes sense, backtrack and correct as needed. And that's the part which we're really excited about. But I want to be very clear here. This is an experimental feature. Do not use it in production. We don't use it as well. But we are still curious to see where this goes and where we can take this in the future. All right. So let's get into it. The code for everything is in the Phidata repo. Fork and clone the repository. Go to the cookbook reasoning folder where you'll have step by step instructions to run the reasoning agents along with examples that work and some that don't work. So again, this is purely an experiment. It's not going to work most of the time, but sometimes it'll work, and maybe we find it useful in some cases where this helps. So after you've cloned the repository, open it up in the code editor of your choice under File Data Cookbooks Reasoning folder. Go to the README file. It'll have step-by-step instructions. Create your Python virtual environment, install your libraries, export your OpenAI key, and then let's test out an example that does not work first. We'll test out the famous counting R's in Strawberry. The only difference between a regular and a reasoning agent is that we set reasoning as true, and Phidata will automatically add a chain of thought and tool use in front of it, and it'll go through the problem step by step. And then along with that, we're going to set when we're printing the response, show full reasoning as true because we want to see the full step output instead of just the title and action. So let's run this. So when we run the strawberry file, we'll see that the regular agent says the word strawberry contains 2 R's. That's very expected. The reasoning agent is also going to fail. So I'm not going to we're not getting our hopes up here. But what I want to show is how it works through the problem. First, it's going to identify the objective. It's going to give a confidence score in its ability to kind of complete this task. And then it's going to break down the problem. Then it's going to solve the problem, then it's going to validate the result and give us the answer. In this case, it still failed, which is expected here. Now let's work through a problem where this actually is a little useful. We're going to work through the logical puzzle of moving the three missionaries, the three cannibals across a river. There's a very fun problem. What we're going to do is we're going to set the reasoning agent and do show full reasoning as true. And let's see what it does then. Okay, let me just copy this up. And so it's going to work through this problem, it's going to think through it. And what I really like is the step by step approach it takes. And I kind of enjoy using this. I want to test it out with a lot of like open source models. But right now, please be careful that it does not work that well with models that are under GPT-4 or like Llama 70B category. All right. So in this problem, it first understood the problem, it analyzed the problem, figured out the constraints, gave a confidence score to it. Then it first set an initial plan to solve it. It's gonna, it's gonna go through it step by step. It's gonna work through like correct its answers as needed. Figure out the problem, and then once it's finalized all the things, it's going to validate its result, make sure it's right, and then give us the answer. But I also like, okay, kind of like give me an ASCII diagram as well because I'm not going to read through the full thing, but I still want to see like how things are working. All right. So again, this is an experimental feature. We are in a place where we like to kind of we should have a lot of like experimental things going on to see what is possible maybe a year, 2 year, 3 year, 5 years from now when the models do automatically get smarter, right? So I want to talk about a little bit. Okay, so instead of like going through all of these like examples, let's do the finance agent one. That's an example which we use a lot, and that actually I like using with the reasoning agent. So in this case, I'm going to do show full reasoning as true. I'm going to do reasoning as true, but also there's one difference. With reasoning, when we are getting the steps, it uses structured outputs from OpenAI. So in this case, because structured output and tool use can't be used side by side together, instead of like setting structured output as true, I'm not going to set it. So this reduces the reliability a little bit, but GPT-4o like returns like the JSON pretty well. So we'll just use the JSON mode instead of structured outputs to so that we can use tools with it. And this is we're going to ask it to write a report comparing NVIDIA to Tesla, and that's where the fun's going to be. So let's run that finance agent for us, and let's see what it does. In the meanwhile, I'm going to just kind of make sure my editor is clean as we're talking through it. So in the finance agent, give it the tools, use tables where possible, and show full reasoning, and let's see. So first, it's going to gather the information. This is the part which I really like. In this, it can run tool calls during the reasoning steps. Fix them. Hey, I didn't get the right result I needed. Let me use another tool to solve the problem. Or wait a second, I'm not really getting the final result. Let me just go down another course of action. So these type of things are kind of like, it's good. It's a good thing to have, a good kind of thing to test with the agents. And I'm hoping that if you're watching this video, you can tell us how to improve them, or like the cases where it doesn't work, or cases that it works really well. I've had a lot of like initial feedback from Phidata users where some found it really good for their use case and they used it to generate like very thorough reports, and some kind of didn't find it that useful. So let me know how you find how it works for you. Okay, so first it compared the company overview, then it presented financial information, then it presented analyst recommendation, compared the news between them, and then gave a conclusion. These types of things are like really good when you break down the problem step by step. Okay, now let's look at the ethical dilemma one and see what it does. Again, in this one, we're not using tools, so structured output is set as true. And then while it's working through that, let's find another example to kind of work on, which we can test, and then we'll call it a day. Okay. All right. Shall we do the ship of Theus? This is a good one. It works really well for scientific, philosophical problems, mathematical proofs. Okay, yeah, let's do the mathematical proof one. Okay, so there's the ethical problem where the train is heading towards five people. You can divert the train onto another track, but there's one person there. So it's going to first analyze the problem, evaluate the utilitarian perspective, then other ones, and then validate the answer, and then give us a response plus a nice little landscape diagram. So all in all, a fun experiment to work with. Now let's go and run the mathematical proof. So prove that for any positive integer n, the sum of the first and odd numbers is equal to n squared. Provide a detailed proof, and it's going to work through that, and then we're gonna cut this video. Okay, so it's gonna first understand the problem, analyze potential hypotheses, create a base case, do step setup, and progression, conclusion, and it's gonna give us a nice little proof, and hopefully it yields good results on the problems that you want to work with. So there it is, folks. This is a very experimental feature that we're testing with agentic reasoning. Again, not a replacement for O1, mostly inspired by it. Doesn't work most of the time, but something which we're very excited about. Play around with it. Give me feedback. Tell the team what do you think of it, where we can improve it, how to improve it, and hope you enjoyed this video. Thank you very much. Have a good weekend. Bye.